Hello students, welcome back. Today we see the another concept of a context-free grammar. It's a derivation and the parse tree. Derivation is nothing but expansion of the grammar rules to derive the given input strings. So here we are going to use the grammar rule to derive a given input string. So if we derive the given input string, we can say the input string is derived by a given grammar, otherwise we will say it is not derived from the given grammar. So the derivation is broadly divided into two types, leftmost derivation and the rightmost derivation. In a leftmost derivation, at each step, the leftmost non-terminal in the working string is chosen for the expansion. So here we are going to choose the leftmost non-terminal for the expansion in each iteration. Where in case of rightmost derivation, it is exactly opposite of a leftmost derivation. In the rightmost derivation, at each step, the rightmost non-terminal in the working string is chosen for the expansion. So here we are moving from left to right. So we will choose the first leftmost non-terminal for the expansion. Where in case of rightmost derivation, we are moving from right to left. So we go on expand the rightmost non-terminal first. So we will take one example for these derivation. So consider the grammar where the grammar contains the rules, that is E produces E plus E produces E into E produces bracket E, and E produces ID. So this is a given grammar, and the string to derive is consider ID into ID plus ID. So we are going to apply both the methods, LMD and RMD, that is leftmost derivation and rightmost derivation, to derive this string. So here check out what are the non-terminal in the given grammar. There is only one non-terminal, that is E here. And what are the terminal symbols here? ID is a terminal symbol, brackets are the terminal symbols, and operators are the terminal symbols. Next, I use the first method, that is leftmost derivation, to derive this string. I will write here LMD, that is leftmost derivation I am doing now. So always you are going to start with the start symbol of the grammar. So what is the start symbol here? E is the start symbol. So I will write E here. So E you are going to derive in such a way that you will get the input string. So as this is a leftmost derivation, I am going to see this input string from left to right. I will read this from left to right. So which operator is there in the left side of the input string? Into is there. So check out. So can I derive ID into ID by using any of the grammar symbols? Yes, I can use the rule number 2 to get this operator and the ID. Okay. So based on the rule number 2, I will derive this E as E into E. Next, so first, which non-terminal you are going to derive? The first leftmost non-terminal. So what I should take for this E? So E here the input string is ID. So check out whether I can derive E with the ID. Yes, I can do that by using the rule number 4. So using the rule number 4, I will derive this E as a ID. Next, into I will write as it is. Next, E I will write as it is. Okay. Next, so this is a terminal symbol. This is a terminal symbol. So next terminal symbol that you are going, non-terminal symbol that you are going to derive is E again. So what I should write for this E? I can write E as ID also. So if I write E as ID, what I get? ID into ID. Whether that is only that is there in the input string? No. The input string has what? ID into ID plus ID. So to take the next terms of the input string, what must I derive for this E? I can derive this E as what? E plus E. So this, the left terminal symbol I will write as it is. Next I will derive this E as what? E plus E. Okay. This is based on the rule number 1. Next, ID into E. So the next non-terminal that you are going to derive is E. So what I should derive for this E? E can be derived as ID. So if I derive it as ID, what I get? ID into ID and plus E I will write as it is. So this is based on the rule number 4. Next, in the next iteration, I will derive which non-terminal? The last non-terminal. So what I should take for this non-terminal? That is ID according to the rule number 4 again. So once I derive this, what I get at the end? That is ID into ID plus ID. So this is same as a given input string. So I can derive this input string by using this grammar, by using leftmost derivation. Okay, next we will see the rightmost derivation also. So I will start with the start symbol. So I am going to derive E again. So E can be derived as what? See, you are reading this string from right to left. So which terminal, which operator you get when you read this string from right to left? Plus is there. So E can be derived as either E plus E, or you can derive it as a E into E. Okay. So I will take here E plus E. Okay, you can go with the E into E, then you substitute this E as E plus E. Okay. So that time also you will get the input string. Okay. So here I will derive this E as a E plus E. Okay. Next, here you are using what? The rightmost derivation. So substitution not start from the left, it starts from the right. You are moving from right to left here. So you are going to derive what? The rightmost non-terminal. So what is the rightmost non-terminal here? E is there. So here before plus, so after plus what you have? ID. So I will derive this E as a ID by using the rule number 4. So once I do that, what I get? E plus ID. Next, see, ID I had a plus. Next, I should derive this E to get what? ID into ID. So which rule I should use for this? So I will use a rule number 2. So by using the rule number 2, I can derive this E as E into E. So this is based on the rule number 2. Next, ID plus is there. Next, I am going to derive a next rightmost non-terminal. So this E can be derived as ID according to rule number 4 again. Next, in the next iteration, so ID plus ID I will write as it is, into also I will write as it is. Next, I am going to derive this E as a ID by using the rule number 4. So this is the rightmost derivation of a given input string. See, the derivation start from right to left. Here the derivation start from left to right. Okay. So I hope you understood these two derivation. The next concept is the parse tree. So once you did the leftmost derivation and rightmost derivation, you are going to represent this derivation by parse tree. So parse tree is a graphical representation of your derivation. So we will see how to draw the parse tree for this LMD and the RMD. So what is a parse tree here? Parse tree is a graphical representation of your derivation. So when I say the tree must have what? The nodes, intermediate nodes and the leaf nodes. The tree leaf nodes always has what? The terminal symbols, whereas the node and the intermediate node have a non-terminal symbols. Okay. So I will draw the tree for this leftmost derivation. So first I will start with the start symbol E. So first I had considered the E as a root node. This is the first symbol I had derived. So I will take that as a root node here. So this E in the next step derived as what? E into E. So I will make a branch of this node, and what I should write here? E into E. Okay. So now these are the non-terminal. So these become a intermediate nodes now. Next, after that, the first E is derived as ID here. So for this E, I will derive it as a ID, where into is a terminal symbol. So I will not derive this again. So as this is a terminal symbol, I will stop here only. Okay. Next, after this, in the next iteration, this E is derived as what? E plus E. So in the next iteration, this E is derived as E plus E. Okay, in the next iteration, I am going to derive this E as a ID. And in the next iteration, I am going to derive this E as a ID. So check out the height of the tree. The height of the tree is, it itself shows you had did the leftmost derivation. Okay. So first you had inserted the value, or you had derived the leftmost non-terminal, then you had moved towards the right. Okay. So next I will draw the parse tree for rightmost derivation also. Again I start with the E. Next E plus E. So E is derived as E plus E. After that, this rightmost E is derived as ID. After that, this E is derived as what? E into E. Okay, in the next iteration, this E is derived as a ID, and after that, this E is derived as a ID. So check out the height of the tree. The height itself shows it is a rightmost derivation. First, the rightmost symbol is derived, then it move towards the left. Okay, or you can take, so as I said, you can derive E as a E into E also. So I will draw the tree for that also. So I will take E as a E into E. Okay, next for this E, see, it is a rightmost derivation. So first I should derive this rightmost non-terminal. So this E is derived as E plus E by considering which rule? Rule number 1. After that, this E is derived as ID first, then this is derived as ID, and the last substitution done for the leftmost non-terminal, that is ID again. So you can derive E as a E plus E or E into E. Okay, so you will get the same thing. So this is all about the derivation and the parse tree. We will see one more example for this. Take a next example. Here the given grammar is S produces AS BS, S produces BS AS, S produces epsilon, and the input string that you are going to derive is AA, BA, BB. So to derive this input string, I am going to make use of these grammar rules. Okay. So first I start with the S. So what is so this is a LMD. So LMD means the leftmost derivation. So I am going to derive the leftmost non-terminal first. So what is the first input symbol that you are going to read? That is A. So S can be substituted in such a way that I get the first input string character. Okay. So S has a 3 production. Which one I should select? So it has a total 3 rules. So I am going to select the rule number 1. So by selecting rule number 1, S can be substituted as AS, BS. Okay. Next. Again, see, it is a leftmost derivation. So this is a terminal. So what is the next non-terminal? It is a S. So I am going to derive this S. So here A is there. So first input symbol I read. What is the next input symbol? It is again A. So I should substitute this S in such a way that I get a next input symbol, that is A. So which rule I am going to use here? The rule number 1 again. So this A I will write as it is. Next, this S can be substituted as A, S, B, S, and this BS I will write as it is. Okay. Now I have what? A. After that, see, B is already here. So what I should substitute for this S? So this S is a non-terminal here. So using the rule number 3, I am going to substitute this S as a epsilon. So if I substitute epsilon, what I get? A, B. Okay. Next, so A, B I read. What is the next input symbol? I must read, that is A, B, B. So B is already there. So I should substitute this S in such a way that I get a here. So here by using the rule number 1, I am going to substitute this S as A, S, B, S, and this BS I will write as it is. Okay. So now I have what? A, B, A. Next, S, B, S, B, S. Okay. A, B, A. Next, what I want? B. So B is there. Here also B is there. So to keep this b as it is, I am going to substitute this s as a epsilon in the next iteration by using the rule number 3. Next iteration, I am going to substitute this s as a epsilon by using rule number 3. And next iteration, I am going to substitute this epsilon by using the rule number 3. So once I substitute that, what I get? A, B, B, B. B. So I had derived the given input string by using LMD. Next, I will apply the RMD here. So first, I will start with what? So what I want here, the B, I must read the B, okay. So I will substitute this S as what? AS, BS only, okay. If I take a second rule, what I get here? A I get. So what is the first symbol when I see this input string from right to left? It is a B. So that B I get by substituting this S as AS, BS. So this is according to rule number 1. And according to rule number 2, I will substitute this S as a epsilon, and the remaining thing is what? It is BSA. Okay. So now I read the first input symbol. Next I want what? B again. So B means what I must substitute for this? Yes, it is A, S, B, S, and this B I will write as it is. And this A I will write as it is. Okay. So now I have what? B. After that, one more B I want. So this B is already there. So in the next step, I will substitute epsilon for this. So once I substitute epsilon, what I get? I will get B, B, S, A, A. So B, B, A, A is over. Next, what I want? I want B, A. So what I must substitute for this? See, B, A. How I get that B, A? By using the second rule. So by using the second rule, I will substitute this S as B, S, A, S. Okay. So after substitution, what I get? A, I will write as it is. This B, B I will write as it is. Now, see, B is there, next A is there, after that B is there, next A is there. So all input strings are already derived. So, but it has what? Some non-terminal, that is yes. So for this yes, by using the rule number 3, I will substitute epsilon. So if I substitute epsilon, what I get? I get A, B, S, A, B, B. Okay. In the next iteration, I am going to substitute epsilon for this S. So after substitution, what I get? I get A, B, A, B, B. Okay. So this is the input string that I want to derive. Okay. So here I had used the LMD. Sorry, here I had used the RMD, and here I had used the LMD. So based on the input string you derive, go on use the grammar rules. Okay. Next, how to draw the tree for this? So here, yes, I will start with a yes. Then yes, I derived as what? A, yes. Next, B, yes. So I am going to make only the non-terminal as the intermediate nodes. I am not touching the terminal symbols here. Okay. Next, after that, this yes is substituted as what? A, yes, B, yes. Okay. And this I am not touching. After that, this yes is substituted as epsilon. Next, this yes is substituted as AS, BS. So here I will write AS, BS. Next, I am going to substitute this S as a epsilon in this step. After that, this S as a epsilon, and after that, this S as a epsilon. So I will get what? The leftmost derivation tree, or you can say the parse tree. Leftmost derivation parse tree. Same I am going to do for the rightmost derivation. So I will start with the S. After that, S is substituted as AS, BS according to this. After that, the rightmost variable is substituted as epsilon in the second step. What is the third step? Third step, I am going to substitute this S as AS, BS. Okay. After that, this S is substituted as epsilon. Next, this S is substituted as what? It is substituted as BS, AS. Okay. In the next iteration, I am going to substitute epsilon for this, and next iteration I am going to substitute epsilon for this. So I will get what? The rightmost derivation. Check out the leaf nodes here. A, B, A, B, 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 A. Okay. So this is a rightmost derivation tree, you can say, or a rightmost parse tree. Okay. So this is all about the derivation and the parse tree. I hope you understood these problems. Thank you.